Hi there. In this video, we're going to talk about the inverse trig functions. The trig functions like sine, cosine, tangent, and there's some others. What they do is they take an angle and they return a value corresponding to a point on the unit circle. Well, the inverse trig functions are going to do the opposite. They're going to take a value and then return an angle. So let's talk about these. All right, so here we have the unit circle here, and this should be very familiar to you by now because we've been talking about this a lot. And that's because the unit circle is how we define the trigonometric functions. A lot of people think of them in terms of triangles, and that's actually what trig means, but that's a very bad name. They should really be called the circular functions. They all come from the unit circle. And we've been talking about sine and cosine and tangent in particular. Sine gives us the y-coordinate of a point at a given angle. It transforms the angle into the y-coordinate. So for instance, if I take the angle pi over 6, and I take sine of that, sine gives me the y-coordinate, 1/2. Cosine of pi over 6 would give me the x-coordinate, √3 over 2. And tangent gives me the ratio of these, which is actually √3 over 3. If I take 1/2 and divide by √3 over 2, take the ratio of these, that's also giving me the slope of this line. So tangent gives me the ratio of y over x. Okay, that's great. We understand that. Now, what the inverse trig functions do is they do the opposite. Instead of taking the angle and giving a number, they take the number and return the angle. So the inverse sine function, we also call it arc sine, is going to take 1/2 and return pi over 6. It takes the value and returns the angle. The inverse cosine function, or arc cos, takes the √3 over 2. If I plug that into arc cos, I get pi over 6. And if I take √3 over 3 and plug it into the arc tangent function, or the inverse tangent function, I'm going to get to the angle, again, pi over 6. They all return pi over 6, given those coordinates. Now, it's not quite that simple, because if I tell you that the value is 1/2, and we're computing the inverse sine of it, well, what you might notice is there's more than one point on the circle whose y-coordinate is 1/2. This isn't the only one. There's another one over here, right? So there's actually two different angles. There's pi over 6 and 5 pi over 6. So if I'm supposed to take the value and get an angle back, which angle am I supposed to choose? And it's not as simple as that either, because there's actually more angles. If I go pi over 6 and then add 2 pi to it, 13 pi over 6, that also gets me here. Or for this one, there's another angle that gets me here. It's 17 pi over 6. If I go all the way around the circle and then 5 pi over 6 more, that's 17 pi over 6. So this is something we need to be careful about. So when we define the inverse trig functions, we have to stipulate which of those angles we want to be our answer. And the way we stipulate it is as follows. For the inverse sine function, we're only going to take the angle that's between negative pi over 2 radians and positive pi over 2 radians. For the inverse cosine function, we're only going to take the angle that's between 0 radians and pi radians. And for the inverse tangent function, or arctan, we're only going to take the angle that's between minus pi over 2 radians and pi over 2 radians. Why are we choosing those ranges for our functions? Well, it's because those are the very ranges that we need to give us exactly one answer. All right, so for instance, for arc cos, if I tell you that the value that I'm thinking about is 1/2, right? So I'm thinking about the points whose x-coordinate is 1/2. So there's this point, right? And there's also this point. Well, if I insist that my angle lives between 0 and pi radians, that puts me up here. That excludes this point from being considered. So I don't have to worry about that. It also excludes any angles that go around the circle more than once. So that ensures that I get exactly one answer. And for the arc sine function, we insist that the angle lie between minus pi over 2 and pi over 2. Well, if I say that, say, my value is negative 1/2, Well, I'm looking for a point on the circle whose y-coordinate is negative 1/2. Well, in that range from minus pi over 2 to pi over 2, there's only one, right? It's this one right over here. I don't have to worry about this guy over here. So by specifying that range, negative pi over 2 to pi over 2, I ensure that I'm only going to get one answer. And so that is why we have that restriction. So let's go ahead and compute some of these values a little bit more carefully, all right? So we're going to compute all of these. Okay, let's start with the first one, arc sine of negative 1/2. I think we were just talking about this, right? I'm looking for a point whose y-coordinate is negative 1/2, all right? But I'm also insisting that the angle be between minus pi over 2 and positive pi over 2. So this is the only point right here. Like I said, there's another point over here, but that's outside of that range that we specified. So this is the only point that we need to consider. So now I say, well, arc sine is giving me the angle. Now I might look at this picture and think, well, look, my angle is 11 pi over 6. But that doesn't work. That's not an angle between minus pi over 2 and pi over 2. So what angle is? Well, I can go backwards negative pi over 6. That angle, negative pi over 6, is in the range negative pi over 2 to pi over 2, and so that is my answer. Okay, let's look at the next one here. We have arc cos of negative root 2 over 2. So I'm going to look at the points on the circle here whose x-coordinate is negative root 2 over 2. Now I see two of them, one here and one here. But remember that for our cosine, we only look at points whose angle is between 0 and pi. So that excludes this angle. I have to be looking at this one. What is the angle measure? It's 3 pi over 4. Is that between 0 and pi? Yes, it is. So that's my answer. Let's look at this one. Arctan of negative 1. Well, remember, tangent gives me the slope. So I'm looking at points whose slope of their line segment joining to the origin is negative 1. Well, that's this one over here, and it's this one up here. So there's two options. But remember that arctan will always give a value between negative pi over 2 and pi over 2. So that excludes this point. It can't be this one, must be this one. Now I'm supposed to get the angle. Well, the angle can't be 7 pi over 4 because 7 pi over 4 is outside of the required range. So instead I go negative pi over 4. That will get me here. So negative pi over 4 is the answer. Let's look at these next three here. Here I'm going to take sine of an angle and then take arc sine of it. Let's think about what happens here. If I take sine of 5 pi over 6, what am I getting? I'm getting the y-coordinate of the point at this angle. Well, let's see, 5 pi over 6 puts me here. What's the y-coordinate? It's 1/2. What's arc sine of 1/2? Well, there's 2 points who have y-coordinate 1/2. There's this one and this one. And arc sine is only concerned with the one between negative pi over 2 and pi over 2, so I'm looking at this one. And now I have to find the angle that's between negative pi over 2 and pi over 2 that puts me here, and it's pi over 6. So this is interesting, because even though we started at 5 pi over 6, we ended up at pi over 6, because of that restriction that the angle has to be between negative pi over 2 and pi over 2. Let's look at this one. Arc cosine of negative 2 pi over 3. Well, cosine of negative 2 pi over 3 is the x-coordinate at that angle. So negative 2 pi over 3. So here's negative 1 pi over 3. Negative 2 pi over 3 puts me here. The x-coordinate is negative 1/2. Okay, now if I'm going to find arc cosine of that, negative 1/2, I have to find the points that have that x-coordinate. Well, there's this one, but there's also this one. Which one is between 0 and pi? Well, it's this one. And what's the angle between 0 and pi that gets me there? Well, it's this, 2 pi over 3. Oops, 2 pi over 3. So even though we started with negative 2 pi over 3, we end up with 2 pi over 3 as the answer. And finally, arctan of 3 pi. Well, where's 3 pi put us? Well, we go 1 pi, 2 pi, 3 pi, puts us over here. What's tangent? It's the slope of this line. The slope of this line is 0, right? So tangent of 3 pi is 0. arctan of 0. Well, I'm thinking of points who give me a slope of 0. Well, it's this one and this one. But remember, arctan only gives me angles between negative pi over 2 and pi over 2. So it can't be this one. It has to be this one. So what angle between negative pi over 2 and pi over 2 put me here? What's the angle of 0? So that gives me 0 as an answer.